So standard normal distribution is designed to answer the question, how can we compare different normal distributions? And hopefully you've had a moment to write down the example here. And I'm continuing on my pet theme with dog tail lengths are normally distributed with mean tail length 38 centimetres and standard deviation of 2.9 centimetres. And I've asked you to compare a dog tail length of 45 centimetres to a cat tail length of 33 centimetres. Now, one comparison would be the dog tail length is longer. Very well done. You have passed kindy maths. However, what it doesn't tell us is how long is that dog's tail relative to all dogs compared to how long a cat tail length is relative to all cat tail lengths. Okay, so we don't like which animal here has a longer tail for its species? Don't know. It's hard to tell. So what we're doing is this kind of idea. If I drew the dog or the dog's tail length as a normal distribution, I didn't say it's normally distributed, but if it's not, we can't really start, then I would have a mean of 38 centimetres and 45, the thing we're looking for, would be somewhere here. Somewhere there. I don't know how accurate I've got that. If I looked at a cat, which I'm going to squish now, and I looked at its mean, which is 30 centimetres, then its mean is here. Sorry, the cat that we're looking at, the cat in question of 33 centimetres, would be, I don't know, somewhere here. And I can't tell whether this percentage, I suppose, is better than this percentage or bigger than this percentage. So I can't see the relative position. So what we do is we convert both into a standard normal. Now, in a standard normal, we use a mean of 0, and that allows us to place the cat somewhere here and the dog somewhere here. There's supposed to be little question marks there. And we just need to work out where the cat and the dog is placed on this standard normal distribution. So we're trying to level the playing field by standardizing the results. Now, I've used cats and dogs, but you could use the same thing when it came to, say, for example, tests. You've got 2 tests, but one for biology and one for mathematics, and you want to see whether how well you're doing in biology compared to math. But in biology, the score was out of 100, but had a mean of 65 and a standard deviation of 12. And for math, the score was out of 100, but it had a mean of 47 and a standard deviation of 2. Then, you know what you got on the test. Where are you performing better relative to your cohort in biology? You need to be able to standardize it to see how you're going. So this is what the process does. It standardizes so that you're comparing like for like. This is the process of standardization. Won't take me long to show you. So in a standardized normal curve, we would have the bell curve. The mean is 0, and the standard deviation is equal to 1. So I've got -1, -2, -3. This time, because I'm just adding 0 to it or subtracting 0 to it, they are literally the numbers I've got here. These aren't just the sigma values, but the actual values here. So 1, 2, 3. So it looks like that. And what you need to understand is that it is basically, remembering that we've been looking at functions, basically the standard normal is a transformed, and you don't need to know the transformations, is a transformed probability distribution function. Every time I write PDF, I think of the PDF doc, but I mean probability distribution function. So the notation is Z is distributed normally with a mean of 0 and a variance of 1, which means that the standard deviation is also 1, because 1 squared is 1. Now, the transformation calculation, which I'm going to go through next lesson, because I can see that I've run out of time. The calculation is we work out the new value on the standard normal by taking the original value, x, taking away the mean, and then dividing by sigma. Now, good news is you don't need to know why. The glimpse is this is a sequence of transformations. So we look at the probability distribution function and we can get a new value by transforming the old value by subtracting the mean and dividing by sigma. Close the door, please. Okay, so that is a glimpse into why it works. In tomorrow's lesson, I'll go through the example of the dog's tails to show you exactly how to compare it. So just to finish off with, probably doesn't need to be captured in the video, but I'll leave it there. What we've done is 16B, 3, 6, 7, 8. We haven't done questions 10, 11, 12, and 13 and 14 here. We'll do those tomorrow. As long as you are aware of what standard normal means, you'll be able to watch these videos and they'll make sense to you. But yeah, we will come back and start with questions, finishing off the example with the dog tails so that you can do 10, 12, 13, and 14, and then you'll be doing some more problems based upon the examples in these videos.